TornadoMix technology for the agitation of liquids. The technology can be used for industrial production and research works, specifically to make up mixes, blends, suspensions, emulsions, extracts, and more. Unique advantages of the technology include easy mixing of both low or high viscosity liquids, no foam or bubbles during the mixing process, instant vigorous mixing at low speeds, more intensive mixing with larger quantities of liquids being mixed, no contact between liquids and mixing driver, energy saving. Concept of TornadoMix. The core principle of the new technology is the steering of a vertically placed container with the substances to be mixed. Radial ribs extend upward from the bottom of the container. Rotation of the tank with such a structural design generates three types of forces between the wall of the tank and the liquid: centrifugal, gravitational, and frictional. This scheme shows the movement of liquid inside the tank. At the start of rotation, the ribs work together with a centrifugal force. They push the liquid from the triangular space between the ribs towards the wall. The space empties instantly, and the layer of liquid above the triangular space drops down to fill the empty space. The entire volume of liquid is set into motion. The liquid is pressed by the centrifugal force against the wall, where it acquires a horizontal rotation. Simultaneously, the liquid is forced to rise along the walls of the container. At one point, the gravitational force overwhelms the force that causes the liquid to rise, and the liquid drops down into the triangular space, repeating the cycle. As a result, the liquid receives 3D mixing. This hydrodynamic process defines the extraordinary features of the TornadoMix technology shown in the tests below. Mixing process. The first test. A container is filled and rotated at 200 RPM. The mixing affects the whole liquid instantaneously. A wall-to-wall whirlpool appears. As the speed is increased, the whirlpool elongates until it reaches the bottom of the container. Simultaneously, the water level rises along the container walls. Contacting surface between water and container increases, and thus intensity of the mixing increases likewise. Mixing process. The second test. The starting speed of the container is 500 to 700 RPM. The effect is incredible. Mixing begins instantly and appears explosive. Water rises towards the top of the container and then drops to the bottom. There, it is pushed by the ribs back to the walls and moves upward again. In this way, the water gets a 3D rotation, which is extremely effective for mixing. Important note. Centrifugal forces that press liquids against the walls increase friction forces driving the liquids dramatically. Accordingly, the larger the diameter of the container, the more intensive the mixing process. This feature makes TornadoMix especially prospective for mixing products in bulk. The mixing of a significantly larger volume of liquid or significantly more intensive mixing at given volume barely increases the load on container driver. This feature makes TornadoMix very energy efficient. Mixing process, the third test. This test shows the character of mixing provided by TornadoMixers. The container is filled with water. Ground pepper is added and then settles to the bottom of the container. Rotation starts at about 450 to 500 RPM. All of the particles are lifted immediately and mixed by the flow of the water. The suspension is ready in seconds. Mixing of foam-forming substances. In this test, liquid soap is dissolved in water 1 to 2. Mixing proceeds at speeds of 200 to 400 RPM. As seen, when mixing is complete, no foam or bubbles appear. Mixing of high viscosity liquids. On the following screen, you will witness the mixing of high and low viscosity liquids, honey and water, and of two high viscosity liquids, honey and molasses. For high shear mixing, the container is equipped with additional meshed ribs. In the first test, 3/4 of the mix is water and 1/4 honey. The speed of rotation is about 500 to 600 RPM. Mixing process is very intensive. The mix is ready in about 1.5 minutes. Now, honey and molasses in equal proportion are mixing. Despite the increased viscosity, the intensity of mixing remains extreme. The mix is ready in 2 minutes. Important note. In both tests, the viscosity of the liquid had insignificant effect on intensity of mixing and on the load on the container's driver. This is yet another stimulus for industrial use of tornado mixers. Dissolving of solid particles in liquids. Now you can see the mixing of nickel sulfate in water. Two tests with the same quantity of substance are performed simultaneously, one with the TornadoMixer and one with the current mixer. Intensity of the color and number of particles at the bottom of the container clearly show which of the devices works better. Complete dissolving of the substance requires 30 seconds for the TornadoMixer versus about 1 minute and 10 seconds for the current mixer. TornadoMixer is 2 times more effective. Preparation of extracts. Comparison of extracts from dry tea in lukewarm water prepared using the TornadoMixer and the regular mixer is shown in this test. The extracts made after 1 minute of mixing are shown. The right glass holds the TornadoMixer extract, while the left glass holds the current mixer extract. The difference in favor of the TornadoMixer is obvious.